Hello everyone. In this lecture we will discuss about the diffusion of component A through non-diffusing component B. With the help of example we will find the flux velocity and the pressure gradient along the diffusion path. So in this lecture mostly we will discuss about the flux, the velocity of components and the pressure gradient of component. There are two components. One is component A and the second one is component B. And the component A is oxygen while the component B is nitrogen. Oxygen is diffusing through nitrogen along the diffusion path of air, and the air consists of nitrogen and oxygen. So this is the problem. A test tube which is 1.5 centimeter in diameter and 12 centimeter tall is partially filled with a solution of alkaline Pryogallate. This is a solution which absorb a lot of oxygen, but it slowly absorb or non-absorb the nitrogen. So it doesn't absorb nitrogen, but it rapidly absorb the oxygen. So this solution absorb oxygen from the air, and when oxygen is absorbing in this solution, the oxygen molecule are diffusing through the non-diffusing nitrogen molecule. So the oxygen is component A, which is diffusing component, and nitrogen is non-diffusing component B. The depth of empty space above the solution is 5 centimeter. The temperature and pressure of the system is 1 atm, and we assume that air consists of 21% oxygen and 79% nitrogen. So the diffusivity of oxygen and nitrogen is given to us 0.21 centimeter square per second. This is a test tube which is 1.5 centimeter in diameter. This is the air which consists of oxygen and nitrogen. Oxygen is component A, nitrogen is component B. The test tube is 12 centimeter tall, and this is the alkaline Pryogallate solution. And this is the air which is flowing around the test tube. The air is at 25 degree and 1 atmospheric pressure. The empty space above this solution is 5 centimeter, which is L or height or Z, anything you can say to it. So this is 12 centimeter tall and alkaline Pryogallate solution. The oxygen molecule will diffuse it will diffuse through the nitrogen molecule. This black are nitrogen and this green one is oxygen molecule. So oxygen molecule will diffuse through this nitrogen molecule, and it will absorbing in the alkaline Pryogallate solution. So the question is what is the absorption rate of oxygen from air into the solution? So what is the absorption rate of oxygen in this solution? What is the absorption rate? So how many oxygen molecule will be absorbed in 1 second in this solution, or how many molecule will be absorbed in 1 minute or some other time? So the rate of absorption of oxygen molecule from air in the solution at steady state. So we should find the rate of absorption of oxygen or the rate of diffusion of oxygen. Diffusion or absorption is same. So from air into the solution steady state, if the air flow gently over the top of the test tube, so if air slowly flow around this test tube. Also make plot of PA PB along the diffusion path. So also make a plot of the partial pressure of oxygen along this 5 centimeter long path. So what will be the partial pressure of oxygen along this diffusion path? What will be the partial pressure of nitrogen along this diffusion path? So we will make a plot. So find the partial pressure gradient of oxygen. The second part is find the partial pressure gradient of oxygen midway in the diffusion path. So what will be the partial pressure gradient of oxygen in this midway? In this is 5 centimeter, this is 0 centimeter, and this is the 5 centimeter. So I am writing it. This is the 5, this is 0 centimeter. It is starting from this position, and this is 5 centimeter, and this is mid, this is 2.5. So what will be the partial pressure gradient of oxygen in this middle position? So we will find this one. Now midway of the diffusion path, calculate the molar average velocity of the mixture. So and the diffusion velocity of nitrogen, oxygen at the top, middle and the bottom. So what will be the diffusion velocity of oxygen and nitrogen in the middle at the top? So what will be the diffusion velocity of nitrogen, oxygen at this top position, in this position, and at this position? So what will be the velocities of nitrogen and oxygen at these three positions? And what will be the molar average velocity? So of the mixture, which is made of nitrogen and oxygen. And the fourth part is calculate the flux of component. What is the flux of oxygen and nitrogen midway in the middle of the diffusion path with respect to observer twice moving with twice molar average velocity at a location in the direction away from the liquid solution. So if observer is moving with the molar average velocity with twice molar average velocity, so for example, if observer is moving in this direction, if observer is moving with twice molar average velocity, suppose this is the molar average velocity, and he is moving in the direction opposite, so we will put minus. So if observer is moving in this direction, so what will be the molar flux of component A and the component B in this case? If observer is moving in a direction away from the solution with the molar average velocity double, with double of the molar average velocity, so what will be the NA and NB, molar flux of oxygen and nitrogen in this case? So now we will find the this is so calculate the flux of component A midway the diffusion path. Now the rate of absorption of oxygen and the partial pressure of oxygen and nitrogen along the diffusion path. This is the part A. So we know that the flux of oxygen in the air or in the nitrogen molecule will be this one, the diffusivity of oxygen in the nitrogen, the total pressure, which is 1 atm. This is the universal gas constant. This is 25 degrees centigrade, and this is 5 centimeter long path. This is 1 atmosphere, and this PL. This PL is 0 atm because the oxygen is quickly absorbing in the alkaline Pryogallate solution. So PL is 0. It is quickly absorbed. The velocity of oxygen at the Pryogallate solution interface is very high. So this will be 0, and PA naught is 21% because air consists of 21% oxygen and 79% nitrogen. So this will be 21 atm will be equal to this one. 0.21 atm will be 0.213 bar will be equal to this one. This is a conversion. The DAB value is given to us, this one. So putting the value, we will get the flux of oxygen molecule in the nitrogen molecule in the 5 centimeter long thick of path of air or nitrogen molecule. The thickness of the air layer is 5 centimeter. And this is the air layer or nitrogen layer, so you can say air layer or nitrogen layer, which is 5 centimeter. This is universal gas constant 1 atm. Now the rate of absorption or diffusion of oxygen. So the rate of absorption or the rate of diffusion of oxygen is nothing but the area through which the oxygen molecule is diffusing in the nitrogen molecules multiplied by the molar flux of oxygen, which we have already obtained, which is equal to this one. This is the molar flux of oxygen in the nitrogen molecule along the diffusion path, which is 5 centimeter thick. So this value is given to us, and this is the cross-sectional area of the test tube through which the oxygen molecule is absorbing in the nitrogen molecule, and then finally go to the solution. So this is the area, this is the radius of the test tube, and the radius divided by 2 is and the diameter divided by 2 is nothing but radius, and the diameter of the test tube is 1.5 centimeter, which is given to us. So this is 1.5 is given to us. Now putting value in this equation, so the rate of absorption of oxygen will be equal to 7.15 multiplied by 10 raised to 4 minus 10 kilomole per second. Now the partial pressure of oxygen along the diffusion path and the partial pressure of nitrogen along the diffusion path, this will be obtained from this equation. Diffusion of component A through non-diffusing component B. This value is already obtained. This value is given to us. We have in the part number 1 A, we have obtained this molar flux of nitrogen. This value is given to us. This is given to us. and this R and T is also given to us. This P is 1 atm, and this is 0, and this is 21%, and this is 1 atm. So when we change L, so when we change L, the partial pressure will be changes. So we will find the relation between these, and this L value is given, which is 5 centimeter. So we will put, first of all we will put 0.1 centimeter, then 0.2 centimeter. When we put L is equal to 0.2 centimeter, then what will be the partial pressure at 0.2 centimeter. So we will get a relationship between PA and L, which is the diffusion path, and then the PB value will be obtained from this equation. PB is equal to P minus PA, and P is 1, so 1 atmosphere minus PA will be equal to PB. Now we rearrange this equation. This is the, we will get this one, simplify. So at L is equal to 0, phi L is equal to phi naught, which is 0.213 atm, and at Z is equal to 0.1, phi L will be phi A at 0.1 centimeter. So the total pressure is 1 atm, PB will be equal to this one. So you can obtain this C is constant, because this C is nothing but this is given to us. This R and T is given to us, this is given to us, and this is given to us, and this L is variable, this is changing. So when we change L, the L value is given to us 5 centimeter. So as you wish, you can put 0.1, then put 0.2 centimeter, then put 0.3 and 0.4, and calculate the PAL value, partial pressure of component A. And from partial pressure of component A, you can obtain the partial pressure of component B from the relation that PA plus PB is equal to 1 atm. So the partial pressure gradient, the second part is partial pressure gradient of oxygen along midway along the diffusion path. So what will be the partial pressure gradient of oxygen in the middle of diffusion path? So this is this is again the molar flux equation, which is about the diffusion of component A through non-diffusing component B. This is the molar flux of component A, which we already obtained. This is the partial pressure, the total pressure, diffusivity, RT, dPA. This is the partial pressure gradient. So the partial pressure gradient can be obtained from this equation. Rearrange this equation, so we will get the partial pressure gradient, which is this one. This is given to us, this is given to us, this is given to us, and this is obtained in the part number 1. And P, A and P, this is given 1 atm, this is 1 atm. So the PA value, how can we obtain the PA value? So the PA value will be obtained at the middle of the diffusion path. So at the middle of diffusion path, we can obtain the PA value. So the PA value at the middle of diffusion path can be obtained from this relation. So here we will put, in place of L, we will put L divided by 2, which is the middle of diffusion path, which is equal to 2.5 centimeter. So we will get PA. So the PA value is obtained in the middle of the diffusion path, which is 2.5 centimeter. This is constant, which is equal to this, this is constant, which we already discussed about this one. So PA value will obtain 0.113 bar in the middle of diffusion path. So putting the value in this equation, this in place of PA, we will put this one. So the partial pressure gradient of oxygen in the middle of diffusion path will be equal to 4.15 bar per meter. This is the partial pressure gradient of oxygen in the middle of diffusion path. Now the third part is the molar average velocity of the mixture of oxygen and nitrogen. So the molar velocity of oxygen is molar flux of oxygen, the concentration of oxygen, and the molar flux of oxygen is this one. This is the, in place of Ca, we will put Pha divided by RT, PA, and this is the RT. Na value is obtained in part number 1, where Z is 5 centimeter, this is 2.5. So we will find the velocity of oxygen in the middle. At this position, we will find the velocity of oxygen in the middle of diffusion path. So the PA value will be 0.113. In this equation we will put 0.113. so here we will put, so the velocity of oxygen in the middle of diffusion path is 8.88 multiplied by 10 raised to power minus 4 meter per second. So the velocity of oxygen in the middle, so in this position you can check, in the velocity of oxygen in this middle position is 8.88 multiplied by 10 raised to the power minus, this is in the middle position. Now this is the velocity, this is the partial pressure gradient, and this is the velocity. Now the velocity of nitrogen is equal to the flux of nitrogen and the concentration. So the flux of nitrogen is 0, so the velocity of nitrogen will be 0. Now the molar average velocity is obtained from this equation. The UB is 0, so this is in place of CT, we will put P divided by and we will and Ca divided by Ct will be equal to Pa divided by Phi, and this Ua is obtained, which is this one. So we will obtain the molar average velocity of nitrogen and oxygen. So the molar average velocity of oxygen and nitrogen is this one, 9.9 multiplied by 10 to the power 5 meter per second. Now at z is equal to 0, we will find the velocity of nitrogen and oxygen at the top of diffusion part, in the middle of diffusion part, and at the bottom of diffusion part. So in the middle we have obtained already. Now at the top, Ua will be equal to Ua naught, and it will be Na, and Ca naught Pa, so it will be Ca naught will be equal to Pa naught divided by RT, and Pa naught is 21% oxygen in the air at the top of this tube. So this Pa naught we will put the 0.21, and then we will get the Ua naught value. So from this equation, now Ub naught will be 0, and at z is equal to 5 centimeter. At the bottom of the diffusion path, the velocity of component A will be this one, because this at the bottom of the diffusion path, the velocity of oxygen will be very high, because the partial pressure of oxygen at the bottom of diffusion path is very high, because the absorption rate of oxygen in the bottom of diffusion path is very high, because we know that PL is equal to 0. So PL is equal to 0 mean that Cl is equal to 0, so the velocity of oxygen in the bottom will be very high, which is equal to infinity or very high. The diffusion velocity of nitrogen with respect to molar average velocity will be equal to the velocity of nitrogen is equal to the velocity of nitrogen minus the molar average velocity. So this will be equal to this one, and the diffusion velocity of oxygen with respect to molar average velocity will be equal to velocity of oxygen is equal to the velocity of oxygen minus the molar average velocity of the mixture. So again this will be equal to this one for oxygen, and similarly for the same process will be applied for z is equal to 0, z is equal to middle, and z is equal to bottom position. Now flux of component A midway the diffusion path with the observer moving with 2u in the direction away from the liquid surface. So when observer is moving in the direction away from the liquid surface, mean when observer is moving with this velocity minus 2u. So then what will be the flux of oxygen and what will be the flux of nitrogen? So in this case the flux of oxygen will be denoted by Na dash, and this is Ca u minus u. So this u is obtained in the part number C, which can be obtained, which is you can apply at the top, middle or bottom. So and this u is nothing but equal to minus 2u, so put this one, this will be equal to ua plus 2u, and Ca in place of Ca we will put Pa divided by RT. So when we obtain the flux in the middle position, so we will put in place of Pa we will put 0.113, which we have already obtained. You can also obtain at the bottom, at the top, as you wish. So the flux of component A, the flux of oxygen when observer is moving in the direction away from the liquid surface will be equal to 4.95 multiplied by 10 raised to 4 minus 6 kilogram per meter square into second. Similarly, when observer is moving with the molar average velocity double value, then what will be the molar flux of nitrogen in that case? So it will be equal to Nb dash is equal to Cv into Ub minus U. But u is equal to minus 2u, so because this ub is 0, because the Nb value is 0, because this problem is related to diffusion of component A through non-diffusing component B. So this will be equal to 0, and putting value minus u into phi b divided by RT, because Cb is equal to phi b divided by RT. Now u is equal to minus 2u. We know that in the direction up away from the liquid surface. So 2u Pb divided by RT, and Pb is nothing but 1 minus Pa, and Pa in the middle position is this value. So at z is equal to 2.5, we will obtain the molar flux of component B in the middle position of the diffusion path. Thank you very much for your attention. If you are new to the channel, please like and subscribe. Thank you very much.